Assalamualaikum and a very good day to all the viewers. My name is Muhammad Farhan bin Abdul Aziz and I will be presenting trend analysis of rainfall in Bentong using Mann-Kendall and also SandSlope. So what is rainfall? So rainfall is actually a water vapor condensed from the atmosphere and then it becomes heavy and then falls under the gravity. And so rainfall is actually a natural phenomenon where it is a most important hydrological cycle and it actually balances the weather and also the ecosystem. But due to rapid urbanization, it starts to changing the natural ecosystem cycles, which is actually leads to the climate change. This climate change will change the rainfall trends. The changes of the rainfall trends will basically cause a natural disaster such as droughts, which is due to lack of natural rainfall, and also floods, which is due to the excessive rainfall. So in order to proceed with analysis, we have to go for the rainfall trend. The rainfall trend need to be analyzed for droughts and also floods control. However, to analyze this rainfall trend, we must require a good quality of rainfall data set in order to proceed for the trend analysis. Unfortunately, this requirement is very hard to be obtained because usually rainfall data obtained is insufficient and also full of missing data. So it comes to our objective, which is to investigate the missing data of the rainfall in time series and also to analyze the trend of the rainfall. The scope of this project is actually we will get the data information only limited from the Department of Irrigation and Drainage (DID). We basically have two departments, which is DID and also another one is MMD, which is Malaysia Meteorological Department. Unfortunately, the MMD, the sources of the rain gauge across Malaysia is very limited, while DID it is well distributed all across the country, so that's why DID is chosen. So next one is the study region only focus on the Bentong area. So in Bentong, it's actually located in the middle of the Peninsula Malaysia. It is quite questionable if it is more affected by the monsoon of northeast or the southwest. It is always usually facing droughts and also floods, but it is not comprehensively studied by the hydrologists or the past researchers, so that's why Bentong is one of the study area. So next is the time series length only focus on the 20-year period between 2000 until 2019. So the literature review will review the past researchers and compare their methods. So first one is missing rainfall data. So the first one is IDW, inverse distance weight. The pros is it is widely used by the hydrologists, but unfortunately it's a very old method and also lots of inaccuracy. The next one is ACID, which is average correlation and inverse distance. It can capture large number of total stations, but it is not a popular technique and it is limited knowledge sources, which basically ACID is a very new technique and there's not a lot of sources. And next is EM method. It is a very easy technique and it performs better than IDW. It is also a very popular and widely used. The problem is it is quite little inaccurate if excessive data is being missing, but compared to ACID and IDW, EM have a better accuracy compared to these two, so that's why EM is the one that we choose. Next is strength of the rainfall analysis. The first one is a Mann-Kendall. It is not affected by the missing data, and it also performs better when the time series period is longer. The concept is not suitable for the seasonal weather like winter. Next is SSE, which is SandSlope estimation. It shows the increasing and the decreasing trends of the rainfall, but the concept is not really a concept, it's actually just moderate in terms of the result. Next is organ. it actually executes the rainfall intensity and it is suitable for the heavy rainfall simulation, but unfortunately it is not widely used. Next one is Spearman raw test. Is actually able to examine the median and mean of the lowest and the highest rainfall, but it's very complex in terms of the formula, and it may lead to the misinterpretation when we executing the analysis. So based on this four, the best two is Mann-Kendall and SSE. So we will both do the analysis with these two methods. Next is the methodology. So for the methodology, it is divided into 3 steps, which is the first one is preliminary stage. Obtain rainfall dataset from the Department of Irrigation and Drainage (DID). And that is proceed to stage 1, which is missing data investigation by using expectation maximization (EM) method, and also the stage 2, trend analysis of rainfall by using the Mann-Kendall and also the sand slope estimation. So for the first stage, which is missing rainfall data, the EM method, it consists of 2 steps, which includes the first one, the E step, and also the M step. It will go through this whole condition. If it passes, it will get the value, which is theta ml. If it doesn't pass the condition, it will repeat the whole process all over again until we get the theta ml, which is the generated value to replace the missing data. So next is stage 2. First one is sand slope estimation, which is can be denoted as Q, whereby the value T can be obtained from the previous equation. So that's how we got the sand slope for trend analysis. So next is Mann-Kendall. The Mann-Kendall can be denoted as ZMK, whereby the parameters S and variance S can be obtained from the previous equation. To interpret this one, if the ZMK is bigger than 0, the trend is increases. If the ZMK is less than 0, which is negative, we'll get a decreased trend. So as a result and the discussion, the first one is the stage 1, which is the missing data analysis using an EM method. So this one we are going to use SPSS statistics software. So this is basically the monthly rainfall after we get the EM analysis. So the blue colors is blue highlight represents the original value that already existed in the rainfall dataset, but the pink highlight represents the missing data, which is not there when we first got the dataset from the DID, and then later after EM analysis, these values are being generated. We can see 3 patterns here. The first one is usually the value take somewhere in the middle, the average, like 1.1. It takes the average between 2.3 and 0.0. Next one, we have a very diverse values where excessive missing data on October 2011. It has a bunch of different values. And also the third pattern is we get the exact same value for a long period of time, like here April 2006, on April 2003, or something like that. So if it comes to our sense and logic, it doesn't make sense at all if we get the exact same values back to back for a long period of time. But this is not considered as errors. This is how the EM analysis works. Despite the curiosity and questionable output, we also need to be realistic that it is near impossible to guess the excessive missing data for a long continuous period of time. So also EM have a very high accuracy, compared to other methods. So this output is actually acceptable. So next, the stage 2, which is the trend analysis. Before we go through the trend analysis, we must first to go through the data classification in time series. So it is crucial to prepare this data into the classes so we can see the trends for monthly, also the monsoonal season, and also the annual. So what we can see in here is actually the combination of the multiple trends, the multiple patterns. We have we can see that the maximum rainfall is usually around month of November, which is actually occurred on November 2006, which actually peaked at 728.9 millimeters, followed by somewhere in the middle of the December 2010 and also January 2011 at peak of 600 mm. And also we can divide all of these into 4 seasonal monsoon, which is the first one is the first intermonsoon, and then southwest monsoon, second intermonsoon, and the northeast monsoon. So we can actually see the pattern, the amount of the rainfall for each monsoon to be quite slightly different, and this can be interpreted in this table. So we can see that the highest monsoon rainfall occurs on the northeast monsoon, which is between September until February, and that is followed by the southwest monsoon 138.9, which is occurred between March until June. And then we also, during the intermonsoonal season, it has less amount of rainfall. And also we can see that the northeast monsoon have a lot more rainfall compared to southwest monsoon, which is we expect it to be. It is considered as the driest season is the intermonsoonal season, which is occurred on June until September. So now we can proceed with the SSE, which is, and also Mann-Kendall. So for this analysis, we're going to use completely software XLStat, and we can see first of all the sand slope estimation. There is a majority of them have positive values, except for the March and April it has negative values. We also can see that the smallest values of sand slope is somewhere on the first intermonsoonal season and also the southwest monsoonal season, which is all near to the zero. And next we can see at the mean, we have the most minimum is occurred on July with 75.1, and also February 77.7. The maximum of the mean ever happened is around November and also December. It means it has a lot of rainfall during this month. So when it comes to the analytical test to investigate the rainfall trends using the Mann-Kendall, it is statistically quite significant with the values of the sand slope. It's quite same with each other. It has quite the same output, just a little different values. We also can see the significance here. There's a lot of sign. So first of all, the double sign of double stars, it indicates an increasing monotonic trend, which means it has 1% possibility of the analysis to making an error when rejecting the null hypothesis. So next, So this happened during May, and also for the northeast monsoon. So next is a single star. The single star is actually a significance level of 0.05, which means 95% of the significance interval in the SSE. So next is the plus sign. The plus sign is occurred on October annual, which means a 0.1 significance level, which means it has 10% possibilities that this analysis is making an error. So basically, the plus sign have less accuracy compared to the double stars. And also next, the dash sign. It indicates that significance level is bigger than 0.1. So next, the Mann-Kendall analysis, the Z values, and also we compare with sense slope. We can see that only on March and April consists of negative values. The rest contain the positive values. These negative values, which we can conclude as these months, March and April, faces a negative trends. And also during the first inter-monsoonal season and the southwest monsoonal season, the value is very near to the zero, and we can conclude that this time there is no trend at all. It is the rainfall trend is not increasing or decreasing. So in conclusion, we can say that all of the objective has been achieved, which is to obtain the data from the DID, and then first objective is to find the missing data using expectation maximization, and then also later we study the trend analysis using the Mann-Kendall and also the sense slope. And then as for recommendation, it is recommended that we compared all the methods of the results. Not only we use the EM method, we can also maybe choose the other methods, and then we compare the results, so we can get a better accuracy for the trend analysis. Also we can study for the temporal rainfall patterns. So the temporal rainfall patterns is actually to study the intensity of the rainfall. And also it is recommended to the forecasting. Forecasting is for us to estimate the floods and the droughts analysis. So but this too is not covered in our syllabus, in our project, because it is due to time constraint. So in conclusion, that this is a further kifaya, this engineering works, because without us we will be questioned why we don't do this certain of things. So that's all from me. Thank you very much and have a good day.